Hello friends, in the last video we have seen how we can determine the position and velocity of a particle when this is moving with a non-uniform acceleration. That is, if an object is moving with a non-uniform acceleration, we cannot apply a formula that is s is equals to ut plus half at square, v square is equals to u square plus 2as, or v is equals to u plus at. So we have to do this by integration. So when an object is moving in a straight line, if I want to find what is the x coordinate, what is the velocity of that object, and acceleration is not constant, in that case I will use method of integration to find position and velocity of the particle. And what is given in such kind of situation, instantaneous acceleration is often given. So if you know the instantaneous acceleration, you can calculate the velocity, and from velocity you can calculate the position of the object. So this problem is called motion with changing acceleration. So the statement of this problem is, Sally is driving along a straight highway at t is equals to 0 when c is moving at 10 meter per second in positive x direction. C passes a signpost at x is equals to 50 meter. Her x acceleration as a function of time is given by this expression. That is, ax is equals to 2 meter per second square minus 0.1 meter per second cube times t. Now the question says, find her x velocity vx and position x as a function of time. So we have to find her position and her velocity as a function of time. Now in this problem, acceleration is given. So this is the instantaneous acceleration. So you see, the instantaneous acceleration is a function of time. So this means acceleration in the x direction is not constant. So I can say acceleration is not constant. So this acceleration is not constant. So now I cannot use those formulas, that is the three kinematical equations that we derived earlier. So in this case, constant acceleration formula is not valid. We cannot use that. So what we have to do is, we have to solve this problem using integration. So we have to apply integration. If you remember, in the last video we derived formula for change in velocity in the x direction is equals to acceleration in the x direction multiplied by dt, and then you have to integrate from t1 to t2. Now let us say what are the things that is given in the problem. So it is given, that is, when c is moving at 10 meter per second in positive x direction, c passes a signpost at x equals to 50. So let's say initial position is given, that is x1 is equals to 50 meter, and this is at t1. t1 is 0. So 0 second, let us start, we start time from 0 second. And initial velocity is given, that is 10 meter per second. So we know, let's call at t1 velocity is v1, that is 10 meter per second. We have to find at any time t2, let's call t2 is equals to t, what is my velocity? So let us plug the acceleration in this expression. So we have delta Vx, and this is equals to integration t1 to t2, and acceleration in the x direction is given by this expression, that is 2 meter per second square minus 0.1 meter per second cube times t, and this has to be integrated from t1 to t2. So let us perform this integration. Delta Vx is nothing but v2, that is the velocity at time t2, minus v1, that is velocity at time t1. Now this integration is relatively simple. So this is constant term and integrated with respect to t. So this will become 2 meter per second square multiplied by t, minus this will become 0.1 meter per second cube, and integration of t is t square by 2. And basically at this point of time we are using a formula that is integration of x raised to the power n is equals to x raised to the power n plus 1 and this divided by n plus 1. So if I use this formula, integration of t will be t square divided by 2. Now I have to integrate this between two limits t1 to t2. So let's put t1 is equals to 0 and t2 is equals to t. So we want to find what is the expression of velocity as a function of time. So if you integrate this will become v2 minus v1 and now upper limit is t, so plug value of t, so the same expression you will have, that is 2 meter per second square times t minus 0.1 meter per second cube, and this is t square divided by 2. Now once you put t is equals to 0, this whole expression will be 0. So this minus 0, which has no meaning basically, so there is no need to subtract 0. So now I know velocity as a function of time, that is v2 is equals to v1 plus, and v1 I know, what is v1? That is 10 meter per second. So I can plug this value, so that is 10 meter per second plus 2 meter per second square times t minus 0.1 meter per second cube t square divided by 2. So this is the expression of velocity at any point of time. Now you have seen that if I integrate acceleration, I get the velocity. Now the second part of the question says you have to also calculate position. So this means I have to integrate velocity now. So if you remember, for position we have expression delta x is equals to integral vx dt, and this goes from time t1 to time t2. So at time t1 position is x2, so delta x becomes x2 minus x1, where x1 is the position at time t1, and this is equals to vx dt t1 to t2. And now I know expression for vx. Vx is nothing but v2 at any point of time. What is the expression for velocity? That is this expression. So I can plug this expression. So x2 minus x1 is equals to, time starts from 0 to t. t2 is t, t1 is 0. And vx is this expression, that is 10 meter per second plus 2 meter per second square times t minus 0.1 meter per second cube t square, and this divided by 2. I have to integrate this with respect to time. So now if you integrate this will be x2 minus x1. This is equals to, so this is a constant, so this will be multiplied by t, and then this is t, integration of t is t square by 2. So this is t square by 2 minus 0.1, this is 0.1 meter per second cube, and integration of t square is t cube by 3, and we also have 2, so this becomes t cube by 6. And this we have to integrate between limits 0 to t. So you see, if I plug t equals to t, I will have the same expression, and when I put t equals to 0, I will have 0. So this is simply x2 is equals to x1, and what is x1? It is given in the problem, that is x1 is 50 meter. So at time 0, the x1 is 50 meter. So I can plug this value. So this becomes 50 meter plus 10 meter per second times t plus 2 cancels out, so I will have 1 meter per second square t square minus, I can write 0.1 meter per second cube divided by 6 and t cube. So this is the expression for position at any point in the future at time t. So this is the first part of the problem in which we calculated position at any time t and velocity at any time t. Now the second part of the problem says when is her x velocity is greatest. So when we will have maximum velocity in the x direction. So if you have some idea of calculus, if I want to have Vx is maximum, then, and Vx is a function of time, then I have to satisfy this condition, that is dVx divided by dt or dVx over dt is equals to 0. So this is the condition for maximum. And you have to also show that d2Vx divided by dt square, this is negative. So this is the condition for maximum. So if I plug this, that is dVx by dt is equals to 0, from there I can get time when this will happen. And dVx by dt is nothing but acceleration. So basically what we have to do, we have to simply put x equals to 0, and from there I can find the time when her velocity will be maximum. So corresponding time will give you the maximum velocity. So what was the acceleration? So if you remember, expression for acceleration is x is equals to 2 meter per second square minus 0.1 meter per second cube into t. So this was the expression for acceleration. So we have to equate this with 0. So if you equate this with 0, you will have t is equals to 2 meter per second square divided by 0.1 meter per second cube. So this will be 20 seconds. So we will have after 20 seconds, that is t is equals to 20 seconds, the velocity will be maximum. So at this point of time, velocity is maximum. Now next part of the problem says, what is the maximum x velocity? So we have to find what is the velocity at time t is equals to 20 seconds, because maximum velocity occurs at t is equals to 20 seconds. What was the expression for velocity? If you remember, we earlier calculated expression for velocity, that was basically v2. General expression for velocity was 10 meter per second plus 2 meter per second square times t minus 0.1 meter per second cube, and this multiplied by t square by 2. So this was the general expression for velocity. This means now if I put t is equals to 20 seconds, I will get the maximum velocity. So what is this value? So this is 10 meter per second plus 2 meter per second square, and time is 20 seconds minus 0.1 meter per second cube, and this is 20 second square divided by 2. So this is equals to, if you calculate, this will come 30 meter per second. So this is the maximum velocity that she will attain, and this will be attained at time t is equals to 20 seconds. Now the next part of the question says, where is car when it reaches its maximum velocity, x velocity? So we have to find what is the x position when it reaches the maximum velocity, and you remember that b maximum happens at t is equals to 20 seconds. So this means I have to calculate x at time 20 seconds. So position at 20 seconds. So if you remember, we have expression for x coordinate, that is x2. So we derived this expression, that is 50 meter plus 10 meter per second times t plus half 2 meter per second square, and this is t square minus 1 by 6 0.1 meter per second cube, and this is t cube. So this was the expression that we derived for position at any time t in the future. Now what is x? So we have to plug time t is equals to 20 seconds. So this means 50 meter plus 10 meter per second multiplied by 20 second, because time is 20 second, plus half 2 meter per second square. So this is 2 meter per second square multiplied by 20 second square minus 1 by 6, 0.1 meter per second cube, and this is 20 second raised to the power 3. So if you calculate all this, you will find x is equals to 517, that is 517 meter from the x equals to basically at time t is equals to 20 second. So we can find what is the x coordinate at time t is equals to 20 second, and this will be 517 meter. So we calculated the x velocity, x position and maximum velocity, and what is the time and when this maximum velocity occurs. Now let us try to plot all this. So we will first plot acceleration. So we will first plot acceleration, that is ax. So what was the expression for ax? If you remember, ax was 2 meter per second square minus 0.1 meter per second cube times t. So this was the expression for acceleration. If I want to plot this, let us say I have, this is my x-axis and this is my y-axis. On the x-axis I am plotting time. So time is on the x-axis, and on the y-axis we have acceleration. So x-axis is time and the y-axis is acceleration. How this graph will look like? So this is the equation of line, and when t is equals to 0, what is acceleration? 2 meter per second square. So if you plug t is equals to 0 in this expression, acceleration is simply 2 meter per second square. And now this is a straight line. So this is a straight line, it will go something like this. So we can show negative y-axis also. So this is the acceleration. So important point, you see up to this point of time, basically we can calculate this time when the acceleration is 0, that is x is equals to 0. Then if you plug this, you will find t is equals to 20 second. So at t is equals to 20 second, acceleration is 0. Before this time, acceleration is positive, and after this time, acceleration is negative. This means before t is equals to 20 second, the car is speeding up. So this is a case when car is basically speeding up. And after this time, acceleration is negative, so a speed is decreasing. So slow down motion. So this is a case where the speed is decreasing and this is slow down. And at time t is equal to 20 second, you have maximum velocity. That is, acceleration is 0, this means maximum velocity increasing and then start decreasing. This means you will have maximum velocity at t equals to 20 second. Similarly, let us try to plot velocity in the x direction. So we have expression for velocity, and this expression is 10 meter per second plus 2 meter per second square times t minus half of 0.1 meter per second square t square. So let us plot this. On the x-axis we will have time, and on the y-axis we will have velocity in the x direction, that is vx. Now what is velocity at t is equals to 0? So if you plug t equals to 0, you will find vx is 10 meter per second. So vx is 10 meter per second. Now what kind of this graph? So this is a graph of parabola as a function of t square. So this is a graph of parabola. Now we also know at t is equals to 20 second, velocity is maximum. So somewhere here at this point velocity is maximum. So this means velocity is increasing and then velocity is decreasing. So I can plot the graph So this should look something like this, because this is a parabolic in nature. So that's why this velocity will something like this. So you can see the first velocity is increasing and then it is decreasing. So velocity is increasing. In this case, in the first case, it is increasing up to t is equals to 20 seconds, and after t is equals to 20 seconds, velocity is decreasing. Basically, you can find at what time its velocity will be 0. In that case, what you have to do? You have to put this expression is equals to 0, and then you have to find value of time. So plug Vx equals to 0, and then you find time, and this will give you expression for time or value of time, where this is going to cross the x-axis, that is time axis. So I leave this problem for you. You try to solve this and put the answer in the comment box. Now finally, I can also plot displacement or position as a function of time. If you remember, we have position as a function of time, that is basically x2. x2 is nothing but position as a function of time, displacement as a function of time, and the expression for this is 50 meter plus 10 meter per second into t plus 1 meter per second square, and this multiplied by t square minus 1 by 6, 0.1 meter per second cube tq. So this is a cubic equation. So if I want to plot this, on the x-axis we have time, and on the y-axis we have position, that is x coordinate. Now what will the position at t is equals to 0? So this corresponds to t is equals to 0. You will have velocity, not the velocity, position, that is 50 meters. So this graph will start somewhere here. Let's put this, or let's put somewhere here. So this is x is equals to 50 meter. So this graph will start this point. Now this is a cubic function. Now you see, in cubic function we can decide whether this is concave up and whether this is concave down, depending upon d2x by dt square value. So d2x by dt square, this is nothing but dvx by dt, this is nothing but acceleration. So if my acceleration is positive, then we will have concave up, and when acceleration is negative, we will have concave down. And at what point you have acceleration is equals to 0? So this means, if you remember, we said for t is equals to 20 seconds, the acceleration is 0. And before that time acceleration is positive, and after that time acceleration is negative. This means at t is equals to 20 seconds, we have point of inflection. That is, curve is changing its nature. Before 20 seconds, we have concave up. So concave up, this means something like this. And then after this, we have concave down. So concave down, something like this. So you see, so this is concave up to this point to this point, and then this point is a point of inflection, t is equals to 20 seconds, and this curve has changed its nature, and this becomes concave down. So in this case, I can say this is concave up and this is concave down. So curve has changed its nature. So this is the position time graph. So in this video we have seen how you can calculate velocity and position if instantaneous acceleration is given. So first is, if you integrate acceleration, you will get the velocity, and once you have the velocity, you can integrate further to get the position. And once you have expression for velocity and position, you can find at what point of time you have maximum velocity, what is the x coordinate at given point of time in the future, and you can also plot the graph of acceleration, velocity and displacement as a function of time. In this case, the acceleration graph is linear, velocity graph is parabolic, and the displacement graph is cubic, that is 3-degree graph. Third order cubic equation, third order polynomial. So I hope you enjoyed this video, and if you enjoy, please share with your friends, and I will see you in the next video with some more interesting topic. So for the time being, bye and take care.